This is an example of an application of the 6895 99.7 rule. So from the book, this is chapter 3, problem number 27 at the end of the chapter. So it says here that there's an intelligence scale that looks about normal, and it has a mean of 100, standard deviation of 15. And they're asking what percent of adults are intellectually disabled based on this chart. And the other piece of information that they give is that people with scores below 70 are considered disabled. So the first thing I want to do when I see a problem like this is draw a graph. So I'm going to just put a very rough graph here. Now we know it's a normal curve, so I'm just going to draw that out. And now I know that my median is going to be in the middle, because when we apply these rules, we assume that the median is in the center, or the highest point of the normal curve. And the median they gave us, I'm sorry, the mean, my bad, the mean is 100. So they're giving us some information. So they gave us the mean is 100. So this is 100, and this is the mean. They also gave us a standard deviation of 15. So if I draw that in, I'm going to go out one standard deviation on either side here, and that's going to be in green. And the distance is going to be 15. So the distance from the mean to the first standard deviation is going to be 15, which makes this point to the left is going to be 85. And the point to the right is going to be 100 plus 15, which is 115. That's one standard deviation. So I'm just going to say this is one standard deviation here. Now if I go out one more, out here, this is going to be two standard deviations, so this is going to be 70. So it's 85 less 15. Or you could say 100 less 2 times the standard deviation, so 100 less 30. I'm just doing it just incrementally here. So 115 plus 15, which is our standard deviation, and let me just write the standard deviation up here. And then I do this as best practice. I typically write all of these things. I just sort of list them out so that I can have them at the ready. So this is going to be 130 here. So the question, and we can go out another one if we'd like. We can go out the full 3 standard deviations. So if I do another line here, in here, this would be 55, because I subtract 15. And here would be 145. It's not quite lined up, but you see what I'm doing here. So this is 3 standard deviations. And the last one we just did was 2 standard deviations. So the question, we can reread the question, how many or what percent of adults are disabled? So we were given that a score below 70 is considered disabled. So if I'm looking at this chart, this area from 70 downward, this is what I'm looking for, this percentage here. So if I apply the 65, 95, 99.7 rule, what I know is that this is 65% right here. This is 95% right here. So this is 65, 95, and then out one more would be the 99.7 portion. So I know that from this point, and I'll try to draw it in here, but this whole thing here that's 95% of the population in this example. So I'm looking for the stuff that's not in the 95%. So really what I'm looking for is there's 5% on this side. This is 5% here, and this is 5% here, which, it's 2.5%. Because the total has to be 5, because the center here is 95. So half of 5 is 2.5, so that's this half of the curve here, and then the other 2.5% covers this half over on this side. So I have 2.5%, so that is the percent that's considered intellectually disabled. So the answer here is 2.5% are intellectually disabled. So hopefully that is helpful.